I am pleased to introduce our next keynote speaker. Noah Arliss is Senior Development Manager at Workday, and he was also a member of the conference committee. So we appreciate his contribution in going through all the talks that were submitted and helping us set up the agenda. Noah has been leading and architecting large-scale enterprise systems for the past 16 plus years as a principal software engineer and software engineering manager. He has a strong background in enterprise security, distributed systems, platform as a service, and big data technologies. Passionate about software architecture as well as distributed computing, he previously led development teams for Oracle Coherence and was an active contributor to the Oracle Coherence incubator projects, working with partners ranging from finance to online retailers to design performant real-time solutions. Noah currently leads the Fabric team at Workday, focused on applying in-memory data grid technologies to Workday's core architecture. Please join me in welcoming Noah.
Morning, everyone. It's a pleasure to be here. You'll have to forgive me, I'm feeling a little under the weather, so I brought my notes with me just in case I get a little spaced out. It's really a very exciting time to be working in technology, especially in the areas of distributed computing, scalability, and performance. And that's a lot of what I think about and focus on here at Workday, and many of the topics, the tracks, the technologies that we're talking about here at this conference look to solve some different parts of the spaces that we think about a lot. Today I'm going to talk a little bit about what Workday is, what we do, the scale and scope of our operations. And then I'm going to talk a little bit about, how we think about deploying, delivering, and building technologies at scale. Before I do, however, I would be derelict in my duties if I didn't show my safe harbor. So this presentation may have some forward-looking statements, and if you're going to buy Workday, you should make sure you purchase it based on the current offerings in the product. So with that out of the way, let's talk a little bit about Workday. So we are the leading enterprise cloud solution for financials and HR. We build a lot of other applications, including payroll and a bunch of other cool things. We have about 1,800 customers, including a third of the Fortune 500 and proportionally a third of the Fortune 50. We have about 26 million workers under management in our system. And the go-lives are super exciting. We have a go-live just about every day. The growth rate is just incredible. And my father always said one of the greatest luxuries in the world is to wake up and get to do something you love every day. And I have to say, I'm fortunate enough to get to do that. When we start talking about the scale and scope of what we build and the impact that it has, it's a pretty exciting place to be. We process about 57 billion transactions in a given year, and that's up 78% from last year. We do about 189 million transactions a day, with a peak of about 289 in 2016. To give that a little perspective, I did a little Googling. I think Twitter does about 500 million tweets a day. So we're up there. But the difference is, unlike sharing 140 characters with my friends and family, we're doing things like we're paying employees, we're paying suppliers, we're making sure that the books can close at the end of a quarter. Really impactful stuff for our customers. And when you look at the growth rates and when you look at the transaction rates that we're talking about, it's all being driven by our customers and our customer growth, right? We have more and more tenants coming online all the time, and the growth rate's been amazing over the past 5 years, but it's not just the number of tenants, it's the size of those tenants that are coming in. And what this slide is really all about, or what it implies to me, is complexity, right? As you have more users coming onto your system, that implies, there's a lot more you have to manage, there's a lot more you have to orchestrate. As your users get bigger, they're generating way more data. They're generating way more requirements in terms of processing. And so the larger your customer base is and the larger those customers are, the more complex your systems are going to be. And at our core, we have to think about managing this holistically, right? We talk a lot about the power of one at Workday, which is, we have one release train, one code base, and that means that all of our customers are running on the exact same platform. And we engineer things that way so that there's a reasonable set of expectations for our customers, and there's a reasonable set of expectations for the operators that are managing that system. If we had a bespoke solution for everything, chaos would rule the day. It'd be really hard to get to scale if you're doing custom one-offs all the time. And this is one of the measures that we hold ourselves to, right? As the request rates go up, we have to make sure that our response times remain relatively stable. And this is a core belief. This is one of the things we measure ourselves to, but it's not the only thing. Availability is important to us. You know, we pride ourselves on a focus on that and a focus on customer service, because we know that what we do has real-world impact. We know that if we have a system outage, it could impact somebody getting paid. That's an important sense of responsibility that we take on within the engineering teams and within the company as a whole. And we have to fret over the little things. We have to make sure that the system is available, and that when there are failures, that we can manage those failures and deal with recovery. And I'll talk a little bit about that. So what are we doing? My team, yes, we're focused on scalability, and I'll talk a bit about that lens in a minute. But in the end of the day, we're building a platform. We're building a platform, and we spend a lot of times thinking about, platforminess, or what are the foundations that go into a robust platform? What are our APIs? Are they reasonable, sensible, and predictable? Do we have the right contracts between services and teams? Is there good telemetry and visibility into our system? We're a big place now. We have tens of thousands of machines under management. We have thousands of developers. We have to make sure we have a foundation upon which we can build great applications. And that's where we spend a lot of our time. And so when I look at through the lens of distributed systems, what I'm really caring about, or what I'm really looking for, is scalability, right? And we have to think about scalability in the context of that growing customer list and the growing size of our customers' data, right? So when we're sitting in the engine room on the Titanic, we're like, well, can we scale to 2x? Can we scale to 10x? Can we scale to 100x? We have to understand the current limits of our system and the limits of our foundation in order to figure out what the right investments are that we need to make into scalability. Throughput's one of those measurements. It's not the only one. Reliability and availability are core critical foundational elements. And visibility. I can't stress visibility enough, right? Can we measure to reasonable KPIs? Can we have visibility into the system? Do we have traceability into the system? Especially once you start going distributed, right? Because now you have lots and lots of things that you have to keep track of, and you have to make sure that everything's working right. You have to know when something goes wrong. And finally, efficiency. When you start talking about the size, scope, and scale of our operation, we actually have to think about sort of that trade-off between space and time, because that trade-off will impact our bottom line. It'll impact how things go. So we have to think about efficiency as we're building our software. So what do we worry about, right? When we're sitting back in engineering, right, it's not just about this cool new flashy API. We have to worry about what's going to happen when something goes wrong. What's going to cause us to break down on the side of the road and fall over? And we spend a lot of time thinking about this. This is a core tenet of building to the platform, is really thinking through failures and what's going to happen. What's going to cause the system to fail? What are the key characteristics that we can look for to make sure we can sense that that failure is coming? What are the real-world constraints that we put on our application? What are the constraints that our business puts on us? Like, take CAP theorem, right? We care about CP, right? We have to make sure that we have the right answer. Can't have a partial answer, especially if I'm talking about somebody's paycheck, right? I talk a lot about recovery. What does recovery look like, though? What's the mean time going to be to actually bring the system back up? And how can we bring that to smaller and smaller and smaller windows of time? It's not a matter of if something's going to go wrong, right? The law of averages is going to kick in, right? Mr. Murphy's hanging around the corner. If you have tens of thousands of machines under management, if you're working on something like an AWS, the failure rates might be small, but if you're big enough, you're going to see them, and you're going to see them with regularity. So our mantra, right, within the org, what my organization, broader organization thinks about is any customer on any application at any time, right? And that's a pretty big, bold, lofty goal, especially when you have a lot of different applications with different characteristics and behaviors. I can tell you the shape and scope and behavior of one system and one application that's being built on top of our platform will look completely different from another. And so what are the fundamental tenets that we can focus on, right? One is linear scalability. We strive to deliver linear scalability because that will allow us to efficiently throw hardware at a problem where it makes sense, right? And that's a hard thing to do. And the other is to really focus on fault tolerance, fault recovery, to make sure that we can keep the lights on and keep the doors open. And so we've got a lot of growth going on, right? We've got a lot of new applications coming on board. The reality is, I mean, even looking at the last keynote, right? Change is constant. It's constant in this industry. It's part of why I got into it. I wanted to be learning and dealing with things that were new all the time. And so we're constantly challenging ourselves to think differently about how we can solve the hard problems. One of my favorite mentors once said that scalability and availability, it's not salt you can sprinkle into a meal. It has to be a foundational construct. It has to be part of pouring your foundation for your architecture. And sometimes you have to re-pour that foundation to be able to build higher. So you have to be able to embrace change and deal with change and work through it. So, you know, sometimes I think about it as the little API that could, right? We find some piece of technology that's applicable, that's going to help us solve some of our scalability solutions. In-memory data grids are really cool. I think they're awesome. And so, you know, I'm just going to talk about like what we think about when we start bringing a technology like this into, you know, being truly applicable, right? When you start thinking about these, like, an in-memory data grid has a lot of cool functionality built in, right? It's got partitioning, it's got closures and lambdas, it's got queries, it's got eventing, right? I can build staged event-driven architectures. Notice that I didn't say caching. It's not a cache. And oftentimes when people start looking at those technologies, they'll say, oh, it's a cache. I'm going to treat it as a cache, right? But it's a paradigm shift. And to shift paradigms is hard because you have to think about all these new concepts. What are the new rules of physics for this new system? What does an ideal data model look like? And how can I transform my existing data models to conform to an ideally horizontally scalable data model? Right? And that's just the beginning, right? Now I've got to think about operationalizing the system. We have to worry about availability and supportability. We have to think about how am I going to operationalize? How am I going to automate? How am I going to deal with the semantics of the system? They're new. Do I have to worry about item potency? Do I have to worry about retrying? When do I? When don't I? How do I share state? How do I diagnose the system as things are going wrong? You know, it's a paradigm shift. It goes back to change being constant, right? And paradigm shifts are you know, they're hard. They're scary for people at times, right? You often are going through, there's like a curve to it, right? You go through a trough of, you know, there's this new thing you learn and it's disorienting, and that disorientation leads to a destabilization moment, right? Things break, you're not sure how it's going to go. And then you start coming up the other side. You facilitate an environment where you can transformatively learn, where it's safe to experiment and try things. And eventually, you can reorient on a new application design and on a new architecture. But it's hard and it's scary. And if change is constant, you better be ready to go through this once or twice, you know, in your career, if not more. And so if change is constant, right, and I need to experiment and I need to be able to try things out, it means I need to have the space to innovate, right? And if we have a culture that's going to punish failure, that's going to punish, you know, that learning where things are sort of destabilized, you're going to stifle innovation, right? But with great power, right, if we have a culture where we can experiment, with great power comes great responsibility. You know, we're trying new experiments, we're trying new technologies. And being open to change is a critical part of what makes us successful and what makes us be able to go after the largest companies in the world. But one of the things we have to remember is our customers are not our experiments, right? It's not okay to just throw something over the wall and see if it sticks, right? We have to have a culture that is ruthlessly focused on breaking the system ahead of time. We have to build our labs, we have to build our test suites, we have to build our infrastructure, we have to build our CI builds even, to the point where we're constantly breaking things so we have the confidence that we've experienced failure and we know what that failure is going to feel like long before we've ever put it out into production where people are, you know, running their businesses. So our philosophy is to test in anger. It's a really critical part of what we do. Most of these technologies, and really most of any technologies that are super cool, that say they're going to solve a problem, they work great under normal working operating moments, right? When there's plenty of power, when there's plenty of memory, when there's plenty of CPU, and there's no starvation, everything works great. But what separates an interesting piece of technology from a great piece of technology is how these systems operate under failure conditions. When there's adversity in the system, when there's challenging, that's what makes a piece of technology really, really great. And that's the kind of technology we look for. So when we talk about building this platform, we talk about building to scale. There's some best practices that we like to think about. One of the most important is really clear expectations and behaviors, right? When we're building our system, we know it's going to affect other people's lives, whether it's my workmate who's working in operations on 24/7 support, right? Or it's my customer who's actually trying to pay their employees. So, we have to make sure that when we build this platform, we're creating a system that's productive and makes our other developers productive. And good software really has to have clear expectations, right? Follow the principle of least surprise, right? If an API says it's going to do something, it should do it, and it shouldn't have unexpected consequences, right? Because that just makes it really hard to troubleshoot. It should be easy for consumers to learn. It should be easy to memorize, and I can't stress this one enough. It should be really, really hard to misuse, because I'll tell you now, if there's a way to misuse your product, your API, your process, an end user's going to find it. I guarantee it. So make it really hard to misuse. And think about consistency. We think about consistency a lot in terms of behavior, in terms of how it works, in terms of how it's documented, in terms of how it looks. We can't predict the future either, so let's make sure that it's extensible. But it's not enough. It's not enough to think about the platform and your APIs anymore. Right? If you're a software as a service vendor, if you're building a microservice, if you're building anything today, at some point you're going to want to scale that thing. And if you want to scale that thing, you better make sure that you can operationalize it. You have got to think about automation as a first-class citizen and how your tool, your technology, your system will be automated. When it's time to do a patch window, when it's time to change a system, right? We don't want an operator turning cranks, because if they're turning cranks, right, that's really hard to do at scale, right? If you're gonna do that for 1,800, 2,000, 5,000, 10,000 times, like that becomes unmanageable, unmaintainable, and it's error prone, right? So the system has to have an easy to consume, easy to understand, consistent, reliable, maintainable, diagnosable automation. It has to have visibility built into it out of the box, right? You have to be really clear on what's important to measure, why it's important to measure, when you should measure it, and at what frequency, right? Because when something goes wrong in a complex system, it can be systemic. It can lead to systemic failures. So we have to have visibility to be able to do root cause analysis, to be able to understand what's really going on, so we can effectively and efficiently resolve issues as they come up, and more importantly, over time, automate that. So when we see anomalies in the system, we can have an automation agent take action on that instead of a human being. Alerting, the act of alerting is really easy, but I like to talk about it as conscientious alerting, right? If I'm alerting on things that I'm actually self-healing, right? As a developer, I may want to see that I fixed something in my automation, but if that's going to the NOC, right? Those network operations center guys, like, they're going to start ignoring my alerts because I'm alerting all the time, right? So I have to be conscientious about what I'm emitting, and what do I do? What actions do I take when those things come out? In the abstract, it's easy to say, right? But in practice, this is hard stuff. It's hard to get operations going well. It's hard to make it work at scale. Failure detection and recovery is something we think about a lot, right? That truck on the side of the road. I want to detect that. I want to fix it. I want to fix it automatically. And I want to, I don't want to have a failure that requires me to bring anything down at any time. And the other thing to think about is, as you're going through these crazy growth curves, like we are, It's very rare that you get the benefit of a homogeneous environment, right? Because just as I'm going through my paradigm shift with my piece of technology, with my part of the architecture, some other part of the organization is as well, right? Maybe it's a new cloud offering, maybe it's a new virtualization offering, right? So we have to make sure that we're thinking about our systems and we're not locking ourselves into one and only one way of operationalizing it. You know, the fundamental principles need to be there, right? It's got to have the automation and the visibility and the telemetry, but maybe that automation is going to change, right? Maybe the way we do things, you know, today is going to be completely different from how we do it tomorrow. And so I thought about taking everything I said and just having one slide, but I thought maybe, you know, that might be going a little too far. This is one of my favorite quotes. It's one of my best engineers on my team has his own way of saying it, and it's really a mantra that we drive to, right? Which is, you know, as technology providers, this should be our mantra, right? Make the impossible possible. The possible should be easy, and then the easy should be elegant, right? It's not enough, just like I said, just to build a cool API. Like you have to take that paradigm shifting thing that feels completely impossible and make it impossible and then make it easy. You know, a lot of times when I think about the complex systems that we build, I think about the movie Back to the Future and Doc Brown, that crazy mad scientist who built the flux capacitor and talked about gigawatts and powering the time machine. Like if you need that kind of engineer to build your system, you know, the amount you're going to be able to drive adoption, you know, whether you're a technology provider like me or a vendor, like you're going to be limited to who you can reach, right? But if you can make it easy, then you can drive much broader adoption, right? Can you constrain the scope of what you're doing so it's easy to understand? It's easy to reason about. It's intuitive to trace. You know, I think there's one thing I hope you take away from what I'm saying is make it easy, and the rest will follow. That's the magic. Thank you.